Hello friends, welcome to VK Lectures. In this lecture, we will be discussing about Fourier transform. Fourier transform. Here, transforming from one domain to the another domain. So, let's say, for example, we have the domain X here. So, domain from the domain X, we are changing to another domain, that is here it is yes, so X to yes. Similarly, from this is, if you consider it as position and S as momentum, the Fourier transform will do the transformation from position domain to the momentum domain, as well as there is t to omega, where t is time domain, omega is frequency domain or energy domain. T to omega, or if you multiply with h cross omega, it becomes energy domain. So this is how uh, the transformation occurs. So x to s or t to omega. So Fourier transform, what it does is its domain is changing or transforming. Okay, so uh, the Fourier transform is given by capital F of the function f of x equal to, here is a constant, 1 by root of 2 pi integral. The Fourier transform limit is from minus infinity to plus infinity. The integral of f of x times e to the power isx dx. So this integral will transform the function f of x to from x domain to s domain. So this becomes f of s. So Fourier transform in s. So it will be a function of s. Okay. Now two kinds of transformations are there: sine transform and cosine transform. Sine transform says f s of the function f of x equal to, the constant is now root of 2 by pi. Okay, and the integral limits is from 0 to infinity, f of x times sine sx dx. Similarly, the Fourier cosine transform, fc of f of x equal to root of 2 by pi integral, again the integral is from 0 to infinity, f of x times cos sx dx. So this is the Fourier sine transform, while fc of f of x is the Fourier cosine transform. Here are few integrals that we may require while doing the Fourier transform. Integral from minus infinity to plus infinity, sine x by x dx equal to pi. The half limit, that means its half limit 0 to infinity, sine x by x dx is the, it becomes half, so pi by 2. Here it is pi, this is pi by 2. Here the limit is from minus infinity to plus infinity, here the limits become 0 to infinity. Then we have integral from 0 to infinity e to the power ax times cos bx dx, cos bx dx. So it becomes a divided by a square plus b square. So this is a and this is b, a by a square plus b square. Now let's see here, integral from 0 to infinity e to the power minus ax times sine bx dx. So it is b divided by a square plus b square. The integral for cos was, cos bx dx is a divided by, that means coefficient of here x in e to the power minus x. So a divided by a square plus b square. Here it is b divided by a square plus b square. Now the fourth, here we have integral from minus infinity to plus infinity e to the power minus of ax square plus bx plus c. This is an Gaussian, similar to Gaussian function, is equal to root of pi by a times e to the power b square minus 4ac by 4a. It's 4 times a. Now integral from 0 to infinity e to the power minus ax is equal to integral from minus infinity to 0 e to the power ax is both 1 by a. Find the Fourier transform of the function f of t. The function f of t is given as n times e to the power minus a square t square, and Fourier transform, and it is transformed to the frequency domain omega. So it is from t domain, that is f of t, to frequency domain omega. So Fourier transform of f of t will be equal to 1 divided by the constant root of 2 pi integral, the limits are from minus infinity to plus infinity, f of t times e to the power minus I omega t dt. Now that's equal to, let's substitute the values of f of t. So this becomes, n can be taken constant, so n divided by root of 2 pi integral from minus infinity to plus infinity e to the power minus a square t square into e to the power minus I omega t into e to the power minus I omega t times dt. Now this is equal to n divided by root of 2 pi integral from minus infinity to plus infinity e to the power minus a square t square minus I omega t times dt. Now we know that the function integral from minus infinity to plus infinity e to the power minus of ax square plus bx plus c is equal to root of pi by coefficient of the x square, that is a, e to the power b square minus 4ac by 4a. Okay, now we need to substitute what are a and things. So here it is equal to minus of, so this becomes minus of a square t square plus I omega t. So only there is no c term is not there. So what it becomes, n divided by root of 2 pi, and this integral equal to root of pi by coefficient of x square. What is coefficient of x square here? A. What is coefficient of t square here? That is a squared into e to the power minus b square. What is b here? B is equal to I omega. So I omega square divided by 4 times a square. 4 times a square. So that becomes n divided by root pi, and root pi get cancelled. A, so root 2 times a into this one is e to the power minus omega square divided by 4a square. Now this is Fourier transform in of f of s in terms of omega. Okay, so we have started with, this is a function which is Gaussian. So what we arrive at is also a Gaussian function, some constant into the Gaussian, here also some constant into the Gaussian. So Fourier transform, there is a note to be taken. The note says Fourier transform of Gaussian function is also Gaussian. Before going to the next question, we have made a small mistake here. This is integral from minus infinity to plus infinity f of t e to the power plus I omega t dt. Okay, this is also plus, so this becomes minus instead of plus. Again here minus 1 squared, but it doesn't make any difference in the answer though. Okay, so that is it. Fourier transform of the function delta of t. This is a Dirac function, Dirac delta function. So delta of t, so delta of t is delta of t minus c, which is here c is equal to 0, which is the center of the Dirac delta function. So center is equal to 0. Now the transformation is from t to omega frequency domain. So f Fourier transform of the function f of t equal to 1 divided by root of 2 pi integral from minus infinity to plus infinity f of t e to the power I omega t dt. Right now, yes, so that's equal to let's write what is f of t, that is 1 divided by root of 2 pi integral from minus infinity to plus infinity. F of t is delta of t and e to the power I omega t dt. So for Dirac delta function, we know that center is 0. So center is lying between the limits minus infinity and plus infinity. So delta of t, so for the function f of t, so if it is, this is the function, so the equation is, or the function is e to the power I omega t will take the value at t equal to 0. So 1 divided by root of 2 pi into e to the power I omega t at t equal to the center. What is the center? Center is a 0. So e to the power I omega into 0, that is e to the power 0, that is becomes 1. So that's equal to 1 divided by root of 2 pi. So the Dirac delta function, either the function will be 0 or the entire limit will go to 0. So if the center is outside. So usually for Fourier transform, the limits is from minus infinity to plus infinity. So every point of this center in the Dirac delta function will be always lying between minus infinity to plus infinity. So you will get only constant values, which is a constant. So what is the conclusion from this? the Fourier transform of Dirac function is a constant. The constant function. Find the Fourier transform of the function e to the power minus a mod t to frequency domain. Or as frequency domain function. Now starting with the formula, Fourier transform of the function f of t is equal to 1 divided by root of 2 pi integral from minus infinity to plus infinity f of t e to the power I omega t dt. Now since f of t is mod minus a minus of a mod t, okay, then we will have two values of the function from 0 minus infinity to 0 as well as from 0 to infinity. So just separating it, 1 divided by root of 2 pi. The first integral is from minus infinity to 0 f of t e to the that is a t e to the power I omega t dt plus this one you can make one bracket, so integral from 0 to infinity e to the power minus a t e to the power I omega t dt. So this is the integration. So now what we know from the integral from 0 to infinity e to the power minus a t equal to integral from minus infinity to 0 e to the power a t is equal to 1 divided by a. So just substitute these values. This integral, what can we write? So 1 divided by root of 2 pi integral from minus infinity to 0 e to the power a t and e to the power I omega t. So e to the power a plus I omega into t dt plus integral from 0 to infinity e to the power, so now let's take minus a out, so minus of a minus I omega t dt. So this becomes e to the power something here, then and here also e to the power minus something. So that's equal to 1 divided by root of 2 pi. This one is 1 by coefficient of t, so that is 1 divided by a plus I omega plus this becomes e to the power minus of something into t. So coefficient of t is a minus I omega, so that is 1 divided by a minus I omega. So if you cross multiply, what you are going to get is 1 divided by root of 2 pi into 2 times a 2 times a divided by, it is a square a plus I omega into a minus I omega, that is a square plus omega square. So it's a square plus omega square. Find the Fourier transform of the function cos ax to the k domain. So transformation is from x domain to k domain. So Fourier transform of the function f of x equal to 1 divided by root of 2 pi integral from minus infinity to plus infinity f of x times e to the power I, so k x dx. Now what is f of x here? F of x is cos ax, but we need to convert cos ax in the form of exponential. So e to the power iax plus e to the power minus iax divided by 2. So substitute this cos ax, f of x to cos ax in exponential form. So what we arrive at is 1 divided by root of 2 pi. So again 1 by 2 will come here, 1 by 2 times. Then integral from minus infinity to plus infinity. There will be 2 terms because this has got 2 terms. So integral from minus infinity to infinity e to the power iax into this term, that is e to the power ikx dx plus integral from minus infinity to infinity e to the power minus iax plus or into e to the power ikx. So this one 1 divided by 2 root of 2 pi integral from minus infinity to plus infinity, again this is within the bracket, e to the power iax ikx. So e to the power I x into a plus k, or let us write a plus k into x dx plus integral from minus infinity to plus infinity e to the power I, here k minus a or a minus k we can write, I into minus a plus k times x dx. And what is this? K plus a and k minus a x dx. This is Dirac delta function. This particular integrals are this integrals, and this integral is Dirac delta function, delta of k plus a. Let us write k plus a here, and this is Dirac delta function for k minus a. And just the k is the domain. In the earlier we have seen delta of x minus a, where x is the domain. Here delta of k minus a, so k is the domain. Okay, so this becomes 1 divided by 2 root of 2 pi times this is delta of k plus a plus delta of k minus a. Find the Fourier transform of f of t. So function is having 2 values. One when mod t less than or equal less than 1, that means from minus 1 to plus 1, excluding these 2 points, less than. So within these 2 points the values is 1 mod t. Okay, now when it is greater, that means from minus infinity to 1 and 1 to infinity, the value is 0. So this is what is given here. Now uh, what we say, yeah, the function is a Fourier transform, the equation Fourier transform of the function f of t equal to 1 times 1 by root of 2 pi minus infinity to plus infinity f of t e to the power I omega t dt. Now so we don't have the function from minus infinity to 1, so just rearranging or rewriting this 1 root of 2 pi integral from minus infinity to 1, the function is 0, so 0 dt plus 1 divided by root of 2 pi integral from, sorry, this is minus 1, so minus infinity to minus 1 and 1 to infinity, yeah, that's correct. So then minus 1 to 1, what is the function f of t? That is 1 mod of t, again what do you say, yeah, 1 into e to the power I omega t dt plus again the 1 divided by root of 2 pi, another is from 1 to infinity, that is again 0 dt, there is no function that is in this region. Now what it accounts for, only the first term is equal to 0, here also it is equal to 0, the only middle term is there, so 1 divided by root of 2 pi e to the power I omega t, integral e to the power I omega t is e to the power I omega t by I omega, and the limits are from minus 1 to 1. Okay, now that's equal to 1 divided by root of 2 pi. First let's go with the upper limit, that's e to the power I omega t minus e to the power minus I omega t divided by I omega, and if I multiply and divide by 2, so I will multiply by 2 here and also divide by 2, so e to the power ix minus e to the power minus ix divided by 2I equal to sin x. Okay, so what it gives, so e to the power I omega t minus e to the power minus I omega t divided by 2I equal to sin omega t, so 1 divided by root of 2 pi into 1 by omega, you have to multiply by 2 here, so 2 divided by omega into whatever is inside is sin omega t, so we can remove this root, so this becomes root of 2 by pi into 1 by omega into sin omega t. Find the Fourier sine and cosine transform of e to the power at. To solve this, we have the Fourier cosine and sine transform formulas, that is Fourier sine transform fs of f of x is equal to 2 under root 2 by pi, the integration is from 0 to infinity f of x is, according to this question, e to the power at into sine sx. Now this is from x to s domain. Now we need the transformation to from t to, let us take, to omega. So this will be f of t equal to root of 2 by pi integral from 0 to infinity f of t into sine, we have to move to omega t, sine omega t dt. Similarly, the cosine transform will be fc of f of t equal to root of 2 by pi integral from 0 to infinity f of t sine omega t. Instead of sine omega t we have cos omega t dt. So these two are the formula that we need to use for this question. So we have the formula for Fourier sine transform as fs of the f of t, which is the function, equal to root of 2 by pi integral from 0 to infinity f of t into sine omega t dt. So that can be written as root of 2 by pi integral from 0 to infinity f of t is e to the power minus at into sine omega t dt. Now this integral, we have the formula integral from 0 to infinity e to the power minus ax into sine bx dx equal to b, that is the coefficient of x in sine bx, divided by the coefficient of x in e to the power minus ax square plus b square. So that's the integral e to the power minus at sine omega t dt from 0 to infinity is equal to, so that is coefficient of t is here omega divided by omega square, that is a square is here, a square itself, a square plus omega square. So the fs of the function e to the power minus at is equal to root of 2 by pi into omega divided by a square plus omega square. So this is the Fourier sine transform. Now for the cosine transform of e to the power minus at, f c of f of t equal to root of 2 by pi integral from 0 to infinity f of t times cos omega t dt. So that's equal to integral, that is here, root of 2 by pi integral from 0 to infinity f of t is e to the power minus at cos omega t dt. And for doing this we have the function formula integral from 0 to infinity e to the power minus ax cos bx dx equal to a, that is coefficient of e to the power minus ax here, divided by a square plus b square. So according to this we have fc of e to the power minus at equal to, that is a, that is coefficient of here, it is a, divided by a square plus the omega square into the root of 2 by pi. So this is fc of e to the power minus 80. Scaling property. So what does it says? If you have the Fourier transform f of the function f of x, so you get a function in s, that is f of s, given by the Fourier transform function, that is 1 by root of 2 pi integral from minus infinity to plus infinity the function f of x times e to the power this is isx dx plus isx dx. Now what if we need to find, if you have function f of x, you have f of s, then what if you are finding the Fourier transform of f of ax? This is Fourier transform of f of x. What about the Fourier transform of f of ax? This is the question. The simple formula, that is 1 by a times Fourier transform of or you can write f of s by a. This is f of s. You can immediately write transform to f of s by a, just multiply by 1 by a. Okay. Example, for example, if you have a function f of ax and you get f of s, the Fourier transform of equal to some s plus a. Okay, this is the Fourier transform. Then f of ax will be equal to 1 by a into f of s by a. Wherever you have s here, divide by a. So this is s by a plus a. So Fourier transform is into 1 by a. This don't forget. 1 by a into f of s by a. Okay. Now that is about the scaling property. Now about shifting theorem. It says that if you have a function f of x, its Fourier transform can be written as f of s. Okay. Then what about the Fourier transform of f of x minus a? This would be equal to e to the power is a into Fourier transform of the function f of s. Just multiply this f of s by e to the power is a. That will be the Fourier transform of f of x minus a. The modulation theorem. Now what does the modulation theorem in Fourier transform says is that we have the function Fourier transform from this is x domain, the function of x, f of the f of x means this is Fourier transform of the function f of x, and we are moving from x domain to s domain. So Fourier transform is from x to s, some random domain. Now what does this modulation theorem says? It is based on the Fourier transform of f of x times the cos ax. Fourier transform of f of x into cos ax is half times the Fourier transform, that means the function in s domain, that we have to change to s plus a plus f of s minus a. Now what is f of s? This is Fourier transform of the function f of x alone. Now what will be the Fourier transform of f of x into cos ax? This will be equal to half times f of s will change to f of s plus a plus f of s minus a. These are Fourier transform of f of x into cos ax. Okay, this together you will get this Fourier transform of the function. Here you get f of s. F of s you have to change it to f of s plus a, and this f of s is Fourier transform of f of x. Okay, what you need to just find out what is f of s and then substitute s with s plus a and s minus a. Okay, now next is regarding the Fourier transform of the derivatives. If you have the function f of x and its Fourier transform is given as f of s, this will be some function of s, function of s. Now what about the Fourier transform of first derivative of this f of x? That will be equal to minus is times the Fourier transform of the function. So this will be equal to minus is Fourier transform of f of x. So if you have a function, first derivative of this function, you need to first get the Fourier transform of the original function, then multiply by minus is. Now Fourier transform of the second derivative of the function will be minus is times square f of s. For nth derivative, minus is to the power n f of s. I hope this is clear. Now we know Fourier transform of the first derivative of the function is equal to minus is Fourier transform of the function f of x, that will be equal to minus is into the function, the Fourier transform function f of s. Okay, now here the question is Fourier transform of delta dash of x, the first derivative of the Dirac delta function, so that will be minus is into Fourier transform of delta of x, so that's equal to minus is into Fourier transform of delta of dash of x is 1 or unity, so that's equal to minus is. So this is because Fourier transform of delta of x equal to 1, or simply you can also write 1 by root 2 pi, but this is considered unity. F of k is given by, this is nothing but the Fourier transform of f of x, the integral from minus infinity to plus infinity, f of x into e to the power ikx dx is the Fourier transform of f of x. So this can be written as Fourier transform of the function f of x, and we are getting f of k. We are moving from x domain to k domain. Okay, now find the Fourier transform of delta of x plus sum over n equal to infinity nth derivative d power n by dx power n of delta of x, nth derivative of delta of x. So each time its first derivative, second derivative, we have to take the Fourier transform. So Fourier transform of let's start with writing delta of x plus Fourier transform of n equal to 1 to infinity. So n equal to 1 means first derivative of delta of x plus Fourier transform of second derivative of delta of x. It goes on up to infinity. Now this one we can write it as Fourier transform of delta of x is 1 plus Fourier transform of delta dash of x is minus I, instead of s we have k because it is going to k domain. So plus this is again delta double dash, so minus ik to the power 2 plus again minus ik to the power 3, it goes on. Okay, now this becomes first term is 1, second term is minus ik, so it has a it's a form of geometrical progression with the first term, this is a naught, and the common ratio or the separation is minus ik. Now this is sum of n terms or infinite terms of a, not n terms, infinite terms of a GP. So it corresponds to geometric progression. So what is the sum? Sum is equal to a naught divided by 1 minus r. So what is a naught? A naught is 1 by 1 minus r is minus ik, so that's equal to 1 divided by 1 plus ik. So this is f of k, Fourier transform of the function f of x. Here is the question, find the Fourier transform of e to the power minus x square in k domain. So that is the domain is moving from x to k domain. So we have the Fourier transform formula. Fourier transform of the function f of x is equal to 1 divided by root of 2 pi integral from minus infinity to plus infinity f of x into e to the power I s x dx. So our function is e to the power minus x square, so this becomes 1 by root of 2 pi integral from minus infinity to plus infinity. F of x is e to the power minus x square e to the power I s x dx. So this is equal to 1 by root of 2 pi integral from minus infinity to plus infinity. This is e to the power minus x square, just combine together, e to the power minus of x square plus I s x, sorry, minus ISX dx. For this we need the formula integral from minus infinity to plus infinity e to the power minus ax square plus bx plus c dx equal to root of pi by a e to the power minus, sorry, e to the power b square minus 4ac by 4a. So here there is no constant c here, so that is equal to 1 divided by root of 2 pi root of pi by a e to the power minus b is is is, that is squared b square minus 4ac, so that is 0 because c is 0, divided by 4 times a is 1, so 1 divided by root of 2 pi into root of pi by a, what is a is 1, this is ax squared, so this is 1 here, into e to the power minus s square by 4. So that's root pi gets cancelled. So 1 e to the power minus s square by 4 divided by root 2. So again this is to k domain, so just replace this by k, so e to the power minus k square by 4 divided by root 2. This is f of k, this is f of s. This is a problem for working out. You can work out this problem.